But before explaining how, I will say why. Because there are a number of ways to boot in a secure fashion in different environments. Linaro is participating to another group called Industrial Internet Consortium. In that group, you have a huge number of companies, and they have identified over-the-air updates and security in general as being a major problem today. Even though there are plenty of solutions, the problem is that there are plenty of solutions. So in that group, a group called Automotive OTA Special Interest Group has been created. I'm doomed. And the idea of this group is to make sure that secure boot and update to the secure boot are consistent across different SoCs, so that they don't spend their lives, and OTA solution providers don't spend their lives in adapting to each SoC for those updates. So that's the why we're doing that. We are focusing on the first steps, but ultimately the goal is to have a way to update anything from trusted firmware to OT applications in a standard way. It does not mean that the SoCs will do the same way. It will still be the same optimized per SoC way, but we will provide, the intent is to provide a common interface. So, the why. Now, how? So U-boot is gradually getting some UEFI behavior. And I would say that EBBR is stating now that the UEFI interface is the standard interface between the firmware and what is loaded. What is loaded is not even necessarily an operating system, because it can be a bare metal control loop. So UEFI being the standard interface, then the next logical step is to implement UEFI secure boot as part of this process, to make sure that we have a standard way of securely booting from power on up to the payload is running. So we will be adding some, let's say, elements to U-boot itself. Make sure that it can check the signatures of the payload with the right certificate formats, etc. We will make sure that for production environment, there is a controlled way, there is a fully controlled U-boot behavior, which is essentially means nobody will be able to change from secure boot to non-secure boot, to have a command line to boot a non-UEFI signed. Whoop. I'm definitely not lucky with the server. So it will be very constrained, because it will be very exposed. Now, for the development environment, you will have everything as usual, but we need to have authoring tool to produce fully secure systems. So that is part of the tasks we will do. And then the other main topic is, how do we have secure and persistent variables where we have keys, etc. So that's where there is some complexity. The problem was solved on ARM with Tiano Core, leveraging what's called standalone MM, which is an implementation of UEFI variables in the secure world. So this standalone MM exists today as a as a secure payload, which is directly accessed by channel core as a backend for the persistent secure variables. What we will do is take this backend and ship it as an opt application, so that we can have other opt applications, because we intend also to have a firmware TPM. We need also non-repudiable logs. We need a whole set of functionalities to sit in the secure world. So we can't just have a single payload in the secure world. So we need a dispatcher, so basically we need opt. So we will port the existing monolithic standalone MM as a T application. And we will do additional things around it, or derived from that, which is in U-boot today, U-boot variables and UEFI variables are, UEFI variables are mapped as U-boot variables, or the other way around, whatever. There is a one-to-one mapping. And the idea is to decouple U-boot variables from UEFI variables. Alexander left. Well, he said, bottom line, we did it, but this was not maybe the best idea, because when you do a U-boot script, you don't create a big fat UEFI variable. You just want a U-boot variable. And having implemented UEFI variables as U-boot variables made things complicated when they were not useful. So we will decouple those two and have two separate backing stores for the variables. Yes?
So are you assuming that opt is going to be the, you have to have opt to do this, or are you going to, like, what if you want to use secure partitions? Because in the future, you will have multiple ones, right?
Yeah, absolutely.
Architect it so that you're locked into opt only, right?
No. And we are just developing a reference platform with maybe the communication channel with opt. Maybe it has to be standardized, I don't know. We really try to think forward, even though, for example, when there will be, if we assume that there will be virtualization in the secure world, we may need to use that also to have, let's say, you have a physical TPM, and you implement virtual TPMs with the physical one being the backend. We need to do the same thing for opt, where it has also to communicate with other elements, and it may not be implemented the same way. So if, for example, if another company which has a product which is not opt as a trust application, as a trust execution environment, they may want to leverage that code and tweak it to their environment. So we're not really trying to impose anything. We're proposing a standard interface with a reference implementation, and then you can implement it the way you want. What else? Yes. For UEFI, we have runtime services. It is, we were told that now the general wisdom is not to use runtime services except for get set variables and update capsules. Not using reset. It sounds like Windows is using PSCI library just to reset. So the only runtime services that we're going to consider is get set variables and update capsules. And those get set variables will be done actually on a cache of the variables, not the variables themselves. And if you want to update a variable, we will offer a capsule update version so that you will post the variable updation rather than modify it directly from the system. And we try to think of the use case. Why would you ever change a variable in a production context? This may just be the change of boot order. So bottom line, the concrete use cases we envision is just for the next reboot. So kind of imposing the update capsules for variable updates is not a limiting factor. It is actually a security increase factor. So it looks a good opportunity.
I'm not sure I completely follow that. So you're saying that if you do a set variable, like set an authenticated variable, that you have to do some kind of update capsule, because that's not following the UEFI spec then, right?
So apparently the update, the UEFI, which is in 2.7, is going to 2.8. And in that document, they start to say, let's forget about runtime services and use them differently. I'm not an expert on the topic. I pretend to be, but I'm not. So Grant from R suggested the approach like that, and yeah. Okay. The very idea is, as you said at the beginning, why are we doing that? To be standard. So we don't want to do hacks. Now it's receiving current. What an engineer I'm doing. One other point quite important is, well, before the update capsules, we want also to implement the random number protocol from UEFI, because it will enable a random kernel address space, address space randomization of the kernel. So that will be also one topic that we will add in UEFI implementation from U-boot. Last point, it's more a prospective, at least an idea, that we want to use update capsules to update everything. So that means update U-boot, but maybe trusted firmware, maybe OPT, maybe so the secrets, the certificates, everything. Now, it does not mean that U-boot will actually do the update. We have the idea is to use the UEFI interface, also the capsule update. It will push, let's say, a blob up to say update this and that. And depending on the platform, so for some platforms, ATF, OPT, SCP is a single blob. That is not, you can't change one, or you can't sign specific elements. This is a full thing. Well, we can still pass that payload, that blob, to U-boot. U-boot can be platform specific. So at that moment, U-boot will do, the U-boot of the platform will do whatever the platform can do to perform the ATF update, which may mean another reset to come back to ATF. ATF will do whatever it has to do for the update. If you have systems that have A and B partitions for trusted firmware, maybe the platform can do it. We're not limiting, imposing a way to do those updates. What we would like to find is a way to say that any element of the system can be updated through UEFI update capsules. Hopefully we will find a way to do it, but it's unclear at the moment. So this session is not exactly, you know, a presentation to say we are going to do that exactly. This is a report of what we discussed yesterday between a number of engineers, and please give us feedback on what you think might be the things we missed, or thing you would like to state on this implementation. Oh, one important point. We hope to have a running prototype for San Diego.
From Linux, there's a get set method in the sysfs interface. So are you proposing to chuck that away, or have it dynamically generate a capsule and feed it into its?
Well, this is a runtime service, so you have attached stubs on how to implement the get set variables. We will provide a stub that will actually do an SMC or whatever it will do to actually do the job. But from a user perspective or from an application perspective, the interface to UEFI runtime service does not change.
So then my second question is, you have UEFI capsule updates, but you don't actually say APT there. Will your first implementation do that in APT?
For the update capsules, this will probably be partly in U-boot and maybe partly in OPTI. I have no idea. I just want to have the path. An OTA agent knows UEFI update capsules, call that, pass that to U-boot, and then U-boot do whatever it has to do based on the platform. It may call OPTI, it may not call OPTI, it may call whatever. This is platform specific.
Okay, so the requirement then would be, if I wanted to do a capsule update from Linux, to write my character device with my capsule, reset, get to U-boot, and then have U-boot be responsible for initiating the update.
Yes, we don't want the SoC vendors to do the same tasks, or to we don't want to standardize the hardware. So an SoC vendor has its own version of U-boot, his own extensions, because he may have an eMMC dedicated for secure storage. You may have shared the eMMC. You may have NOR flash involved. You may have NOR flash that support partitioning, NOR flash that do not support partitioning. We don't want to change that. What we want to allow is firmware update this, and then the U-boot platform does whatever it has to do.
So I think your UEFI random number generator needs to live in APT then as well.
I would say at this moment we haven't touched on the how we will do it. We say this is a key component missing. Implementation of random number protocol, UEFI protocol in U-boot, will add it.
Actually, there is an implementation in OPTI for random number generator that I added for us in Racer, so which was used in case of EDK2 to seed the random number generator for the kernel. So there is already an existing, maybe we can
Excellent.
Yeah.
As a developer, as a normal developer being lazy, I'm really happy.
Does it require any hardware backing?
You could have random numbers entropy from like I have for from the thermal sensors to fetch the entropy. There could be other hardware sources we could fetch the entropy to that random number in Opti. So, and you provide the interface to Opti to fetch the random number stream to the U-boot and then provide it to the kernel.
So I would say here this is perfect, and we will not be trying to solve the world hunger. If if there is no entropy hardware, we will not be able to simulate it. But if it's there, it needs to be accessible through U-boot and UEFI implementation, well, UEFI services of U-boot. Other questions? Oh, sorry.
So your goal is to have a prototype of all of these features by the next Connect. Is that correct?
That's correct. And we submitted a talk for ELC in August, and hopefully we'll have at least the secure variable storage backend running. I just saw 0 seconds at the time I said at ELC. Wow. So thank you very much for asking those questions, being there, and join Connect. And see you next time.